Let's see how to find the formula for the sequence -6, -1, 4, 9, 14, and so on. Now, when you're given a sequence, the first thing you should always look at is the difference between consecutive terms, meaning you have to look into what you would have to add to one term to get to the next. Now, starting from the -6 here, we can see that to get from -6 to -1, we would have to add 5. Similarly, to get from -1 to 4, we would also have to add 5. And from 4 to 9 as well, and finally, from 9 to 14 as well. What this means is that the difference between consecutive terms is always the same. Another way of saying that is that the difference between consecutive terms is a constant. When this happens, the sequence is known as arithmetic, which I'm writing down here. Arithmetic. These are also sometimes called linear sequences. Now, for arithmetic sequences, there's a very convenient formula that we can use to find the formula for the nth term directly. The formula is un is equal to u1 plus d times n minus 1. Now, let's just make this a little clearer here. u1 is the first term of the sequence, and d is the difference between the terms. So it's simply d for difference. Now, looking at the sequence that we had above, we saw that the first term was -6, so we can already write u1 is equal to -6, and we also saw that the difference between the terms was always the same and was always equal to 5. So we can write d is equal to 5. Using those two bits of information, we can now write a formula for the nth term, and write un is equal to -6 plus 5 times n minus 1. All we've done here is look at this initial formula that we were given, the general formula, and we replaced u1 and d by their values. Now, we should never leave a formula like this. We should always simplify it as much as possible, and we'll do this by expanding or distributing that 5 across that bracket. This would be equal to -6 plus 5n minus 5. And finally, gathering like terms, this will lead us to 5n minus 11. And we now have a formula to calculate any term we want of the sequence. Now, to be safe, it's always a good habit to pick up to check that it works for the terms that we were given. Just check it for 1 or 2 terms, and that will be enough. Now, we saw in our sequence, remember, the sequence was -6, -1, 4, 9, 14, etc. Let's say, for example, we're interested in the third term, which in this case is 4. That means that u3 should be equal to 4. To check that, we calculate u3. And to calculate u3, all we need to do is replace n in this formula up here by 3. So u3 would be equal to 5 times 3 minus 11. That would be equal to 15 minus 11, which finally leads us to 4. So that's definitely the value we were looking for, and our formula definitely seems to be working there. Just to be safe, let's check it for another value. Let's check it for the fifth term, which I'm underlining here. So the fifth term is equal to 14. What that means is, when n is equal to 5, we should find u5 is equal to 14. So let's see. u5 would be equal to 5 times 5 minus 11. That leads us to 25 minus 11, which finally leads us to 14. So this formula definitely works, and we can definitely conclude by saying that the formula for this sequence is un is equal to 5n minus 11. And we're done.